So as you all know, when the military wants to research and then field a new product, they have to actually build the product many times for testing. And in Iowa, one of our universities has been working with DoD to conduct that testing on human-based avatars. It's cutting down the number of times we have to make products for testing, and it's saving taxpayer dollars, time, and human resources. So Dr. Flagg, can you describe some of the benefits of computer-based avatar testing and any thoughts on that program and how we might be able to expand that through our laboratories?
Sure. I think that it's an incredibly interesting area. I know a little bit about it mostly because we're often asked about why we do animal testing, and so we have to think a lot about when you can use sort of virtual testing and new ways of thinking about how we do testing and when you actually have to put it onto a living organism to really understand it. I think the combination is incredibly powerful. We don't actually have a model of the full human system. We're actually very complex, and while we kind of know how things work, we're not actually able to model the things that are going on inside of our bodies effectively yet. Most people kind of think we must have that, but in science we just don't have that yet, right? But what we do have are sort of the macro understanding of how we interact with the environment. And this is where I think these virtual training systems that allow you to put the person into an environment that wasn't necessarily created specifically with the user in mind, because most engineers, God bless them, think more about the machine than they do the person until we've got to shove one of them in there, right? I think it is an incredible opportunity to be much more thoughtful about that very early on in the engineering. And I think that these types of technologies in Iowa and in many other places, and I think where some of our laboratories are sort of playing around with some of this as well, allows you to work on something in Iowa where a lab in sort of Massachusetts at Natick or something is working on something similar, to be able to compare where you're doing that similar test in your own environments, on your own activities, but to be able to share those results. So I think it increases our ability to integrate across the private sector, academia, and our laboratories. It allows us to much more affordably test very early in the system where we wouldn't necessarily stick an actual human in. And it also allows us to test in environments that are incredibly dangerous and incredibly hostile, and so I don't want to put necessarily a person into every explosion. So there are great ways of using the virtual testing before you actually get to something like We a Man or some of the other activities that we have in the Army that are very expensive. So I think it has an incredibly relevant place in the system, as long as we remember that it's one part of a series of things that need to be done to keep the human in mind very early on and to make sure that we minimize costs, but also that at some point we really know what's going to happen when we put an actual person in.
Very good. I appreciate it. Any other input from our panelists? Dr. Holland?
Yes, it's really important that the environment that we're describing be one that can be validated in some sense, and I think that's what Dr. Flagg was speaking to. From that perspective then, as best these environments can be built from a physics, an understood physics perspective, the more we can believe in them. The more that they are constructed from pure empiricism, for example, the more we are extrapolating on things that we get to the point of guesswork. And then when we add very sophisticated graphics on top of those, then we are drawing beautiful pictures of things that can be pure baloney.
That's a good point.
And in the case of what we're doing for a living, that becomes extraordinarily dangerous because we're involving someone's life in the process. So we've been trying within the department to begin the process of just putting together the key environments that we own within the department to be able to put the best physics-based models together, for example, to see what parts of the flight of an airplane, the design of a ground vehicle, the design of a ship, et cetera, can be done computationally, and how many of those trade spaces can we look at long beforehand, again, from the idea of being able to play a lot of these what-if games to gain insight long before we bend metal. Okay? And those are where we find our best use of the computational world because it generates insight for us. still leaves the human in the loop. But those have to be valid, you must be able to validate them in order to believe them.
Absolutely. Multi-layered approach. Yeah, absolutely. Thank you. Dr. Montgomery?
You know, models are great. They embody knowledge. They capture what you learn and allow you to be able to apply it. Developing them to be validatable and accurate, of course, is a challenge. So, you know, sort of extending from the avatar approach, that, for example, you can make physical models of human structures. You know, that the skull is a mechanical structure. The brain is a elastic material with certain mechanical properties. And so by testing those surrogates, you can get to understand what are the kinds of effects that are going to have consequences for the person. So, you know, if you have a person that suffers a blast, then there's the initial blast, but there's also the shock that reverberates internal to the brain on several iterations as the shock wave penetrates under the helmet and around the head. And certain frequencies of that appear to be more damaging to the brain structures, producing traumatic brain injury than others. So by being able to get a physical sense of that, then one can then feed that into the model that an avatar carries in a larger simulation model, which will then allow you to predict, if I do this to protect them, here's what the efficacy is going to be. Critically important. It takes powerful computers.
Very good. I appreciate that. Thank you very much. And we will move on to, actually, if we can get Senator Warren, and we'll come back to you, Senator Heinrich. Thank you. Thanks, Senator Warren. Thank you. Go ahead.